Assalamualaikum warahmatullahi wabarakatuh. So today our group consists of me, Nur Andrea binti Muhammad Yunus and Nur Umi Umairah binti Zaharuddin will explain how matrices can solve engineering mathematic problem. So our problem is regarding electrical. So the main problem is to find the mesh current of the circuit. So how can we find the mesh current is by using the Kirchhoff rule. So we can make the equation using Kirchhoff voltage law, which is summation of IR is equal to summation of E. So for the first equation that we able to identify with using this law is 15I plus with 10I1 plus I2 because the 10 ohm resistor is sharing with these two loops and moving on the same direction. It will become 10 ohm times with I1 plus I2 plus with 20 I1 equals to 1500 minus with 1500. Why it's minus? Because we need to consider the loop direction and also the circuit, the current flows. So it goes the same for this 5 ohm resistance. So as we identify the equation, we can form the linear equation and then we expand and simplify the equation, becoming like this. And then write it in matrix form, where this is 3 by 3 matrix for the resistor, and then this is the x value, 3 times 1 matrix, the x value that we want to find, and this is also 3 times 1 matrix for the voltage. So by using Cramer rule, we need to find the determinant of the coefficient matrix. So how can we find determinant? Is, for example, I use this column. So for here, plus 45, because we need to alternating between positive, negative, positive, and so on. So positive 45, and then we close this column and row and find this determinant. So A times with D minus with B times with C. And it goes the same for the rest. So we calculate it and we expand and calculate it, and we get 151,000 and 37500 for determinant. And next, we need to find determinant when placing the x value in each column. So first, we put the x values in first column. So we change from the original first column into the x values, and then as usual we find the determinant by using the same way as before. I use this row, the second row, to find determinant, and then this is the answer, negative 2,500,000 negative 250,000 and negative 250,000. Sorry. And then we alternate the x value in second column, and then we find the determinant, and this is the answer, 112, 5 and 5,000. And lastly, for the third column, we put the x value in third column and we find the determinant, and we get the answer, negative 112,500. So by using Cramer rule, we collect we use all this information that we get from determinant, and then for example for I1, determinant I1 divide by determinant the coefficient determinant, and we get the answer, negative 1.65, and for I2 7.43 and negative 0.74. It goes the same for the rest, but we change this determinant I2 and determinant I3 from the answer that we get. That's all for me. Thank you.
Okay, I will explain by using Gaussian elimination method. Okay, this equation I got from the earlier equation that already be simplified. This we change it into the metric form, and this the goals that I want to make. This part must be the identity part, and this part will be the answer that we want. Here, we first thing first, this part must be 1 to make it the identity, and the rest must be 0. Okay, first we focus on this number. We want to make this number became 1, so we make an equation in order to make the 45 became 1. So we apply all the number in row 1 in this equation, and then we got the new number for the row 1. Then the in the column 1, the part this part and this part must be 0, because uh, we want to make sure that the diagonal part became 1 and the rest become 0, right? So we want to make this 0. We make an equation for row 2. So we apply all the number in row 2 in this equation, and then we will got new number in row 2, and we will also get 0 here. After that, we focus on the second part of the diagonal part, which is here. We want, and again we want to make it this part 1, and then we make an equation, and all the number and at row 2 apply in this equation, and we got new number. After that, we focus on the column, second column. We want to make the rest be, became 0 except the diagonal part. So we make any new equation again for row 1 and row 3. So all the number at row 1 and row 2, at row 3, apply in this equation. After that, we will get 0, 0 here, and the rest number of row 1 and row 3 change. After that, we focus on the third part of diagonal, which is here. Okay, like the same thing I did before. We want to make it 1, make a new equation, and then we will get 1. Apply the equation all the number at the row 3. Okay, not only this part. After that, we focus on 0, make this part became 0, so we make an equation for row 1 and an equation for row 2, and we apply the equation, and then we will get the identity here, and then this part will become the answer that we want. Here we already got the answer, and we got negative answer for I1, I3. So we must redraw back the circuit because of the negative answer, because solution for I1, I3, the negative, like said before, means that the initial assumption of the direction of current was incorrect. So we draw a new one. As you can see that all the loops is rotate counterclockwise. All the loop 1, loop 2, and loop 3. So the correct one, we must make sure that the ampere is positive. Okay, the resources we use, and thank you from Nurin and Umi.